Hello there, and welcome to Infinity Beyond, where curiosity takes flight and science becomes a gentle guide into the unknown. Tonight's episode is a calm journey into one of the most mysterious forces of existence: time. Time. It ticks, it flows, it slips quietly through our fingers like sand in an hourglass. It shapes every moment of our lives, yet we understand so little about it. Sometimes it moves fast, and sometimes it crawls, especially when we're waiting for the kettle to boil. But what is time, really? Before we dive into the ticking fabric of this universal enigma, let's take a moment of connection. Where in the world are you watching from right now, and what time is it for you? How fitting it is that a video about time begins by asking the time. It's fascinating, isn't it? That something so integral to our lives is also so elusive. We schedule our days, mark our calendars, celebrate anniversaries, all based on this invisible metric. Yet physicists still argue whether time even truly exists in the way we experience it. Let's begin by understanding the basics. The time we live by is based on astronomical events, Earth's rotation giving us days, its orbit around the Sun giving us years. But that's just the practical stuff. In science, time takes on a far more profound role. In classical physics, time is linear. It's like a straight road. You can move forward, but never backward. Isaac Newton saw time as absolute, a fixed stage on which events unfold. But then came Einstein, and everything changed. According to Einstein's theory of relativity, time is not a rigid backdrop. It's flexible. It bends and stretches. The faster you move, the slower time ticks for you. If you travel near the speed of light, time for you slows down relative to others. This isn't science fiction. It's been proven with satellites orbiting Earth, whose clocks tick just a little differently than those on the ground. And gravity? It pulls on time too. A clock on a mountaintop ticks faster than one at sea level. That's gravitational time dilation, a concept that once lived in the realm of science fiction, but is now a vital correction in your phone's GPS system. But what does this mean for our everyday lives? When you're deeply engaged in something you love, time seems to fly. When you're bored or anxious, it drags. This psychological time, subjective time, is governed not by the laws of physics, but by our brain. Neurologically, time perception is tied to attention and memory. The more information your brain processes in a moment, the longer that moment feels. This is why childhood summers seem to last forever. Our young brains were constantly absorbing new experiences. Now let's explore an even weirder idea. Some scientists speculate that time doesn't actually flow. All moments, past, present, and future, may exist simultaneously in what's called the block universe theory. You are just experiencing one slice at a time. That sounds mind-bending, doesn't it? But here's the kicker. According to quantum physics, the future may already exist. Your tomorrow might be out there, waiting for you to arrive, just as your past still echoes somewhere in the universe. Let's pause. Take a deep breath. As strange as all of this sounds, remember this. While physicists seek to measure and define time, humans live it. We feel it in heartbeats, in sunrise and sunset, in the way we miss someone or anticipate something. So the next time you glance at a clock, remember, it's not just tracking time. It's reminding you that you're part of a grand, mysterious unfolding. Time is the music that plays as we dance through life, one fleeting moment at a time. Stay with us, because in the next segment, we'll explore what time means in different cultures and how ancient civilizations tried to control it using shadows, stars, and sacred rituals. Welcome back to Infinity Beyond, where tonight's exploration continues through the shifting sands of time. In the last segment, we ventured into the physics and philosophy behind time, discovering how Einstein, gravity, and even our own brains influence how we experience this invisible dimension. Now, let's step back even further, not just in thought, but in history. How did ancient civilizations experience and measure time, long before atomic clocks and GPS corrections? The answer is as diverse as human culture itself. From Babylon to Beijing, from the Andes to the Nile, humans have always tried to capture the flow of time, using shadows, stars, water, fire, and stone. Let's begin in ancient Egypt, where timekeeping was closely tied to the cycles of the Nile and the stars. The Egyptians built elaborate sundials and developed a 24-hour day system, 12 hours of daylight and 12 hours of darkness, based on the movement of the sun and certain Decan stars that rose at different times of night. Their priest astronomers were deeply concerned with precision, especially in timing religious rituals aligned with cosmic rhythms. Over in Mesopotamia, the Babylonians based their understanding of time on lunar and planetary cycles. They divided hours and minutes into units of 60, a system we still use today, because 60 is easily divisible by many numbers. They were among the first to keep detailed astronomical records, recognizing that patterns in the heavens could be used to predict earthly events. Their calendars were both practical and mystical. In China, the ancient Chinese used water clocks as early as 4,000 years ago. These ingenious devices, which allowed a controlled flow of water to mark intervals, were used alongside gnomons, vertical sticks that cast shadows to indicate the time of day. But more than just tools, these clocks were symbols of harmony between heaven and earth. The emperor's astronomers aligned celestial and seasonal cycles with imperial rule, believing that cosmic balance ensured political stability. The Maya civilization in Central America had one of the most advanced calendars of the ancient world. They tracked the movements of Venus with stunning accuracy and used multiple interlocking calendars to chart religious and agricultural cycles. One of these was the famous Long Count calendar, which some people mistakenly thought predicted the end of the world in 2012, but in truth, the Mayans saw time as cyclical, not linear, an eternal return rather than a ticking clock. Even Stonehenge in England, mysterious as it may be, is believed by many to be an ancient solar calendar. Its massive stones are aligned with the solstices, moments that would have held great spiritual and agricultural significance for Neolithic peoples. It's clear that throughout history, humans have looked up to the skies not just for wonder but for order. Timekeeping was never merely scientific, it was sacred. It dictated when to plant and harvest, when to fast and feast, when to crown kings or worship gods. But these systems weren't just about counting hours or days. They were ways of weaving human life into the rhythms of the cosmos. By observing the sky, ancient peoples saw themselves as part of something vast and meaningful. In many ways, timekeeping was a spiritual act, an effort to synchronize the human soul with the heartbeat of the universe. What's truly fascinating is that despite the diversity of methods, cultures across the world converged on similar principles. The importance of cycles, days, months, years, reflected a deep understanding of the patterns of nature. This is something modern life, with its digital clocks and artificial lighting, often causes us to forget. And so, as we rush from meeting to meeting or scroll endlessly through timelines and deadlines, perhaps there's wisdom in looking back. The ancients didn't just measure time, they respected it. They aligned with it. They lived in harmony with the sun's arc, the moon's phases, and the stars' eternal dance. In our next segment, we'll turn our attention to biological time, how plants and animals, including humans, are hardwired to perceive and respond to the passage of time. From circadian rhythms to the aging process, we'll see how time lives not just in the cosmos, but in our very cells. Until then, take a moment, step outside, look at the stars. Somewhere, long ago, someone just like you did the same, and saw not just beauty, but a cosmic clock ticking silently through the night. Welcome back to Infinity Beyond. In our previous journeys, we explored the cosmic and cultural dimensions of time, how Einstein showed us its relativity, and how ancient civilizations aligned their lives with the stars. Now we journey inward, into our very cells, to explore biological time. You see, time isn't just something that exists in the sky or on a clock. It's etched into the rhythms of life itself. Every living thing, from the tiniest microbe to the tallest tree, obeys internal clocks. Complex systems evolved over billions of years to help life anticipate and adapt to a world that moves in cycles. Let's begin with the circadian rhythm. From the Latin circa diem, meaning about a day, this internal 24-hour cycle governs when we sleep, wake, eat, and think. Your body's master clock, located in a tiny part of the brain called the suprachiasmatic nucleus, synchronizes your biological processes to the natural light-dark cycle. This clock responds to light, especially blue light from the sun or from your phone. That's why staying up late staring at screens can disrupt your sleep. It tricks your brain into thinking it's still daytime. But it's not just humans who run on a clock. Plants open their leaves at dawn and close them at dusk. Even in constant darkness, they'll follow this cycle for several days. Flowers bloom at precise times of day to attract pollinators. Bacteria multiply faster or slower, depending on the hour. Time is embedded in biology. Jet lag, for instance, is the result of your internal clock falling out of sync with the external world. If you fly from New York to Tokyo, your body thinks it's 3 p.m. when it's actually midnight. That confusion ripples through your system, disrupting sleep, digestion, mood, even gene expression. And yes, your genes follow rhythms too. In fact, a Nobel Prize was awarded in 2017 for the discovery of the molecular mechanisms of circadian rhythms. Scientists found specific genes that turn on and off at certain times of day, like clockwork. Your liver knows when to process sugar. Your heart knows when to beat faster. Your brain knows when to dream. This intricate system keeps you functioning, but it's also fragile. Chronic sleep disruption, like in shift workers or those with insomnia, has been linked to increased risk of heart disease, obesity, depression, and even cancer. That's how important biological time really is. But our bodies also measure time in other ways. Consider aging, perhaps the most obvious biological clock. From the moment we're born, our cells are counting down. Each time a cell divides, the ends of its DNA, called telomeres, get shorter. When they become too short, the cell stops dividing. This built-in limit is part of why we age. Yet scientists are now studying ways to slow or reset these cellular clocks. Could we extend life by repairing telomeres? Could we manipulate the body's timekeeping mechanisms to delay aging or even reverse it? On a different scale, seasonal rhythms also shape biology. Many animals follow circannual clocks, internal timers that help them prepare for migration, hibernation, or mating seasons. Arctic foxes change the color of their fur with the seasons. Birds fly thousands of kilometers at precise times each year. Somehow, they know when to go. Even humans are seasonal to some extent. We tend to eat more and sleep longer in winter. Our mood changes with the length of daylight. Some experience seasonal affective disorder when days grow short. Our hormones and immune systems shift with the seasons. We are not machines. We are rhythmic beings. And then there's the question of subjective time, how we feel time passing. When you're bored, 5 minutes feels like forever. When you're having fun, hours vanish. This isn't just perception. It's tied to how the brain encodes memories. Novelty and engagement stretch time. Routine compresses it. That's why childhood summers feel endless. Everything was new. Everything mattered. As we grow older and fall into routines, time seems to speed up, not because it moves faster, but because we're less present. Understanding this gives us power. Want time to feel fuller? Seek novelty. Try something new. Break routine. Pay attention. You don't need a time machine. You need mindfulness. Biological time is not just science. It's personal. It's how we live, age, sleep, remember, and experience the world. And it's deeply connected to how we feel. Time lives not just in the universe or our cities, but in our blood, our breath, our dreams. In our next segment, we'll leap from the internal to the external once again, to explore what time might look like on other planets. How would time pass on Mars? Or near a black hole? Strap in, because space is about to get very strange. Welcome back to Infinity Beyond. So far, we've explored how humans measure time, how ancient civilizations aligned with celestial rhythms, and how living beings experience time biologically. But now it's time, pun intended, to leave Earth behind. Let's ask a fascinating question. What does time look like on other worlds? How would time pass if you were standing on Mars, orbiting Jupiter, or hovering near a black hole? Let's start close to home. A day on Mars, known as a sol, is about 24 hours and 39 minutes. That's not too different from Earth, which is why some space agencies like NASA simulate Martian schedules during rover missions. Engineers on Earth working with rovers like Curiosity or Perseverance have lived on Mars time, waking up and sleeping based on the Martian clock. That 39-minute difference adds up quickly, throwing off Earth-based routines and making it feel like you're slowly rotating out of sync with the rest of humanity. On Jupiter, things get strange. Despite being the largest planet in the solar system, Jupiter has the shortest day, only about 10 hours long. It spins incredibly fast, creating enormous storms like the Great Red Spot. If you lived there, and could somehow survive, your day would be more like a rapid blur. Venus, meanwhile, is the queen of weird time. It rotates so slowly that a single day on Venus lasts 243 Earth days, but its year is only 225 Earth days long. This means that on Venus, a day is longer than a year. Imagine seeing the sun rise just once every few months. Time behaves differently, not just because of rotation, but because of gravity, a concept we touched on earlier with Einstein's theory of relativity. The stronger the gravity, the slower time flows. This means that near a massive planet or star, time ticks more slowly compared to someone farther away. This leads us to the most extreme example in the universe: black holes. A black hole's gravity is so intense that time practically stops at its edge, the event horizon. According to Einstein's equations, if you watch someone fall into a black hole from a safe distance, they would appear to slow down infinitely, frozen in time. But from their perspective, they would fall in normally, while the rest of the universe speeds up. This concept was famously dramatized in the movie Interstellar. In one scene, the characters land on a planet near a massive black hole named Gargantua. Due to the intense gravity, 1 hour on the planet equals 7 years in orbit. This is not science fiction. It's based on real physics. Time dilation near a black hole could cause massive time gaps between two people depending on where they are. Think about it. Time is not universal. It's relative. On Earth, we assume time passes the same for everyone. But in the cosmos, that idea falls apart. Astronauts on the International Space Station, traveling at 28,000 kilometers per hour, age ever so slightly slower than we do on the surface. It's measurable. It's real. Let's imagine even more extreme environments. Near a neutron star, one of the densest objects in the universe, time is also significantly warped. A minute spent near its surface could equate to minutes or even hours elsewhere. Then there's the idea of interstellar travel. If humanity ever masters travel near the speed of light, relativistic time will become a practical concern. Say you take a journey to another star at 99.9% the speed of light. For you, the trip might last just a few months, but for everyone back on Earth, decades could pass. You'd return to find your loved ones aged or gone, while you've hardly changed. This time dilation is not just an inconvenience. It's a profound reminder that time is not a constant across space. It's a fluid, malleable fabric, stretched by gravity and speed. And when we consider life beyond Earth, whether in future colonies on Mars, moons of Saturn, or hypothetical planets orbiting distant stars, we have to think beyond Earth time. Even our definitions of a day and a year become meaningless. Each world has its own rhythm, dictated by its rotation and orbit. If we colonize other planets, how will we track time? Will we adopt Earth standards or build new clocks based on the host planet's motion? On Mars, scientists have already created special calendars and time systems to help coordinate missions. They've even designed watches that can keep Martian time. In the future, a Martian might say, "Let's meet at 9 sol hours past sunrise." And that might mean something totally different from Earth. As humanity expands into the stars, our concept of time will stretch with us. New clocks will be born, new calendars will emerge, and new generations may grow up with entirely different senses of morning, evening, and the passage of time itself. It's a beautiful reminder that time is both a human invention and a cosmic reality, something we create to find order, yet something that bends and twists in the vastness of the universe. In our next segment, we'll shift into the deepest questions of all. Does time have a beginning and an end? What does physics say about the origin of time? Is there such a thing as before the Big Bang? And could time one day simply cease? Stay curious. Stay timeless. Welcome once again to Infinity Beyond. We've traveled through history, biology, and outer space to understand the many faces of time. But now, we confront a question as old as philosophy itself, and as complex as quantum physics. Did time have a beginning? Will it have an end? Let's begin with the beginning. According to current cosmological theory, time began with the Big Bang, roughly 13.8 billion years ago. Before that moment, the universe, and time itself, may not have existed. In fact, the phrase "before the Big Bang" may be meaningless, because time, as we understand it, didn't exist yet. This concept is difficult to grasp. We're so used to everything having a before and after that imagining time itself as starting at some point challenges our very intuition. Yet, Einstein's general relativity suggests that space and time are interwoven, forming a unified fabric known as space-time. If space emerged in the Big Bang, time likely did as well. So what caused the Big Bang? That remains one of the greatest mysteries in science. Some theories suggest it may have emerged from a quantum fluctuation, essentially a blip in a timeless void. Others propose cyclical models, where the universe expands and contracts eternally, with each cycle resetting time itself. In those models, time may be infinite, looping, not linear. Like seasons repeating endlessly, the universe might be reborn again and again. These are speculative ideas, but they reflect a deep human urge to understand. Where did time come from? And where is it going? Let's look forward now. Will time ever end? According to current observations, the universe is expanding, and that expansion is accelerating due to a mysterious force called dark energy. If this continues indefinitely, we may face a future known as the heat death of the universe. In this scenario, galaxies drift so far apart that light from one can never reach another. Stars burn out, matter decays, and black holes evaporate. Eventually, the universe becomes cold, dark, and empty. Time still exists, but with no change, No events, and no observers, it becomes meaningless. It's a haunting vision, a cosmos still ticking but utterly silent. But there are other possibilities. In a scenario known as the Big Crunch, gravity overcomes expansion and pulls everything back into a single point, a reverse Big Bang. If that happens, time might run backward or start anew. A related theory, the Big Bounce, proposes that after the universe collapses, it rebounds into another Big Bang, beginning the cycle again. Still more speculative is the idea of the Big Rip, where dark energy grows stronger over time, tearing galaxies, stars, planets, and eventually atoms apart. At that moment, time itself might unravel. These are not science fiction, they're grounded in the mathematics of modern cosmology. But they also highlight how little we truly understand about time's ultimate fate. Now let's go deeper, into the quantum realm. In quantum mechanics, time is treated very differently. At the smallest scales, particles don't behave like solid objects, but as probabilities, described by wave functions. Here, time becomes a parameter, a label used to track changes in a system, not a flowing river. Some quantum physicists suggest that time may not be fundamental. Instead, it could be an emergent property, a byproduct of entanglement and change. In certain models of quantum gravity, like loop quantum gravity or string theory, space-time itself may be made of tiny discrete units, like pixels in a digital image. Time, in this view, could be an illusion that only arises at large scales. That brings us to one of the most mind-bending possibilities, the end of time not as a cosmic event, but as a conceptual one. What if time doesn't exist at all? What if it's merely a tool our brains use to make sense of change? In philosophy, this is known as eternalism, the idea that past, present, and future all exist equally, and that our experience of now is just a matter of perception. Under this view, time doesn't flow. We move through a fixed block universe, like a train traveling along a track. This challenges everything we think we know. If all moments exist simultaneously, then every heartbeat, every thought, every sunset you've ever experienced is still there, somewhere. You are not just who you are now, but who you were and who you will be, all at once. Whether time is an arrow, a circle, or an illusion, it remains one of the deepest mysteries in science and human thought. As we come to the end of this segment, consider this. While we search for time's beginning or end, what really matters is how we live within it. Each moment is a miracle. Each second is a spark in the cosmic dark. We are time travelers, moving one heartbeat at a time through the greatest story ever told. In our next episode, we'll explore how our memory and anticipation shape our experience of time. Why does time seem to speed up as we age? Why do moments of joy feel so short and pain so long? Get ready to dive into the psychology of time. Welcome back to Infinity Beyond. We've journeyed through the vastness of the cosmos and the mysteries of quantum physics to uncover the nature of time. But what about the time you feel? The way a summer as a child seemed endless, but your adult years vanish in the blink of an eye? Why does time feel like it's speeding up as we age? And why do moments of fear seem to stretch, while moments of joy disappear too quickly? These aren't questions of physics, but of psychology. This is the realm of subjective time, how your mind perceives the passage of time, independent of clocks and calendars. Let's start with a familiar observation. Kids often say, "Are we there yet?" during a short car ride. Meanwhile, adults wonder how the day passed so quickly. This contrast has a deep neurological explanation. As children, nearly everything is new. The brain is constantly processing unfamiliar information, building patterns, learning language, and forming memories. Time feels slower because more is happening in the mind. Novelty creates density in our memory. Think of it like this. The more new experiences you cram into a moment, the longer it feels in hindsight. That's why a single hour on your first day in a new city feels longer than an hour spent scrolling your phone in a familiar place. The brain records novelty with greater detail, and that richness stretches our perception of time. As we age, life becomes more routine. Our brains recognize patterns faster, so we process information more efficiently, but also less vividly. Days start to blend together. Weeks pass in a blur, and suddenly, you're wondering how another year flew by. This is called the holiday paradox. When you're on vacation, time seems to fly while you're in the moment, but afterward, it feels full and rich in memory. In contrast, a week of routine work may feel long while it's happening, but short in retrospect because there was little variation. So here's the secret. If you want time to feel slower, you need to fill it with newness. Travel. Try a new hobby. Take a different route to work. Talk to someone new. These small acts create memory anchors that slow down the way your brain records time. Let's go deeper. Our emotions also warp time. Fear and stress tend to make time feel slower. In dangerous situations, the brain floods with adrenaline and becomes hyper-aware of its surroundings. It encodes more detail, making the event feel like it lasted longer than it actually did. This is why time seems to stretch during a car crash or intense anxiety. On the other hand, joy and flow states, like when you're absorbed in a good book, a creative task, or a great conversation, compress time. Hours disappear, and you're shocked at the clock. This is called time compression, and it's a sign that you're deeply engaged. Then there's the concept of temporal focus, whether you tend to live in the past, the present, or the future. Some people are nostalgic, always recalling what was. Others are future-oriented, always planning. And some live fully in the moment. Your time orientation can shape your experience of happiness, anxiety, and even health. Living in the present, what psychologists call mindfulness, has been shown to slow the perception of time. When you truly pay attention to what's happening right now, your breath, the sounds around you, the taste of your food, time expands, not objectively, but experientially. There's also cultural variation. In Western cultures, time is seen as a commodity. Time is money, we say. It's linear, fast-paced, something to manage. But in other cultures, like in many indigenous or Eastern traditions, time is cyclical, relational, and patient. The way we talk about time affects how we experience it. Even language plays a role. Some languages frame time horizontally. Past is behind, future is ahead. Others, like Aymara in South America, do the opposite. The future is behind because we can't see it, and the past is in front because we remember it. The more we study subjective time, the more we realize we don't live in time. We create it. Our brains are storytellers, weaving moments into a narrative. That narrative determines whether we feel rushed, relaxed, fulfilled, or lost. And here's the hopeful part. While you can't slow down the ticking of the clock, you can change how time feels by changing how you live. Be intentional. Break monotony. Embrace novelty. Practice presence. Let's summarize. Novelty makes time feel slower and more memorable. Routine compresses time and makes it blur. Emotions stretch or shrink time based on intensity. Mindfulness expands the present moment. Culture and language shape how we think about time. So if you've ever felt like the years are slipping by too quickly, ask yourself, when was the last time you did something for the first time? In our next segment, we'll dive into one of the most controversial and fascinating frontiers. Time travel. Is it scientifically possible? What do physics and paradoxes say? Get ready for wormholes, twins, tachyons, and theoretical trips through space-time. But for now, take a deep breath. You're here, in this moment. and that is enough. Welcome back to Infinity Beyond. We've felt time in our bones, seen it stretch near black holes, and watched it speed up in our memories. But now, we're ready to ask the big question, the one that has fueled countless science fiction stories and late-night thoughts. Is time travel possible? It sounds like fantasy, but science actually has a lot to say on the topic. Let's start by understanding what time travel really means. We all move forward in time, 1 second per second. That's just existence. But the dream is to move faster or slower, or backward. The most scientifically grounded theory of time travel comes from Einstein's theory of relativity. We've discussed how time slows down the faster you move. This has been confirmed with satellites and atomic clocks. If you could travel at 99.999 the speed of light and return to Earth, you might age just a few days, while decades pass for everyone else. That's called time dilation, and it's real. In a sense, this is forward time travel, using speed to cheat the clock. But what about going backward? That's where things get weird and controversial. One idea comes from the concept of wormholes, theoretical tunnels in space-time that could connect two distant points. If wormholes exist, and if one end could be accelerated to near-light speed and then brought back, you'd have a time difference between the two ends. Step into one and emerge in the past or future. It's a mind-bending idea supported by Einstein's equations, though no physical wormhole has ever been discovered. There's also the notion of closed time-like curves, CTCs, solutions to Einstein's field equations that allow for loops in time. These could theoretically let an object return to its own past. But CTCs introduce serious problems. Paradoxes. The most famous is the grandfather paradox. Imagine you travel back in time and prevent your grandfather from meeting your grandmother. Then you'd never be born, which means you couldn't have traveled back to prevent the meeting. Logical loops like this are a huge problem for backward time travel. To resolve this, physicist Kip Thorne and others have proposed self-consistency principles. These suggest that events in a time loop must always be consistent. You can't change the past, only fulfill it. You might try to stop your grandfather, but fail in a way that ensures your own birth. In this view, time is flexible, but not rewritable. Quantum physics offers a slightly different view. The many worlds interpretation suggests that every possible outcome of a quantum event actually occurs in a different, parallel universe. So, if you went back and changed the past, you'd simply create a new timeline. Your original timeline remains intact, and no paradox arises. This theory inspired countless sci-fi works, from Marvel's multiverse to Back to the Future. It's thrilling but speculative. We have no experimental evidence of parallel timelines or alternate realities. Still, some physicists believe time travel may be possible, just not practical. The energy required to create a stable wormhole or manipulate space-time is far beyond our current capabilities. We'd need something called negative energy, which might exist in tiny quantum fluctuations but has never been harnessed in bulk. Even if we had the technology, the risks are enormous. Wormholes might collapse instantly. Traveling faster than light could break causality. And quantum instability could erase entire timelines. But let's not give up hope just yet. There's another fascinating concept called the tachyon, a hypothetical particle that always moves faster than light. If tachyons exist, they could carry information backward in time. But so far, they remain purely theoretical. Some scientists think the key lies not in brute force, but in understanding time itself more deeply. Maybe time travel isn't about machines and tunnels, but about perception, entanglement, or undiscovered dimensions. And here's the twist. In a way, we are all time travelers already. We remember the past. We imagine the future. We carry our stories across decades. Our minds are bridges through time, creating meaning out of sequence. Einstein once said, "The distinction between past, present, and future is only a stubbornly persistent illusion." Maybe time travel isn't about breaking the rules of physics, but about understanding the illusions we live within. So, is time travel possible? Forward? Yes, via speed, gravity, and relativity. Backward? Maybe, in theory, with paradoxes, exotic matter, or multiverses. Practically? Not yet, but our understanding is still growing. And that's what makes science beautiful. Every question leads to more mystery. Every breakthrough opens new doors. Time, like the universe, is still unfolding. In our next segment, we'll explore a timeless topic in a different sense: the philosophy of time. Is the past gone? Is the future real? What do great thinkers, Plato, Kant, and modern philosophers, say about time's meaning? But for now, thank you for journeying through the science of time travel with us. Even if we never step into a machine like in the movies, we've already traveled far, together. Welcome back to Infinity Beyond. So far, we've explored time through the lenses of physics, biology, psychology, and even science fiction. But in this episode, we turn to a different kind of exploration: the realm of philosophy. For centuries, philosophers have debated a deceptively simple question: what is time? We all think we know. It's what the clock measures. It's what keeps everything from happening at once. It's the line from past to present to future. But when you pause and try to define it, time becomes slippery, abstract, and mysterious. Let's begin with the ancient Greeks. Plato believed that time was a moving image of eternity. In his view, time belonged to the physical world, while eternity existed in the realm of pure forms, unchanging, perfect, timeless. Time was a shadow of a deeper truth. Aristotle, on the other hand, defined time as the number of movement in respect of before and after. For him, time was a measure of change. If nothing changed, there would be no time. This view echoes through much of classical philosophy. Centuries later, St. Augustine posed one of the most insightful questions: what is time? If no one asks me, I know. But if I try to explain, I don't know. He argued that the past no longer exists, the future hasn't happened, and only the present is real. But the present is fleeting, a knife edge between two abysses. This leads us to a major philosophical debate. Does time flow? In our everyday experience, time seems to move. The present moment slides into the past. The future becomes now. But is that just a trick of consciousness? Some philosophers argue for presentism, the idea that only the present is real. The past is gone. The future doesn't exist yet. All that exists is now. Others embrace eternalism, the belief that past, present, and future all exist equally. In this view, time is like a landscape. All moments already exist, and we simply experience them one at a time. This idea aligns with Einstein's view of the block universe, where time is not a river, but a frozen dimension. Then there's the growing block theory, which suggests that the past and present exist, but the future does not, yet. The block of reality grows as time progresses. Each of these views has implications for free will, memory, and the nature of reality. If the future already exists, are we truly making choices? If only the present is real, how do we explain causality? Modern philosophers also explore how language and culture shape our understanding of time. Some languages, like English, have tenses that clearly separate past, present, and future. Others, like Chinese, use more fluid structures. This affects not only how people speak about time, but how they experience it. Time can also be seen as subjective structure, a mental framework we impose on the world to make sense of experience. In this view, time isn't out there, it's a cognitive tool. This idea links philosophy with psychology and neuroscience. And then there are thinkers like Immanuel Kant, who argued that time is a condition of human perception, a category our minds use to organize experience. We never perceive time itself. We perceive changes and interpret them as occurring in time. This idea challenges the very notion of time as an objective reality. Maybe time doesn't exist independently. Maybe it's a feature of the mind, not the cosmos. But others argue the opposite. Time may be more fundamental than space, energy, or even matter. Some cutting-edge physicists now suggest that time might be the key to reconciling quantum mechanics with general relativity. Perhaps in some deep way, time is the fabric from which everything else arises. So, what do we make of all this? The truth is, no one fully understands time. Not scientists, not philosophers, and perhaps that's the point. Time is not just a dimension. It's not just what clocks measure. It's an experience, a question, a mystery. It's the rhythm of our hearts and the ticking of the stars. It's the flow of thought and the silence between breaths. It's both intensely personal and unfathomably cosmic. And while we may never find a final definition, our attempts to understand time are themselves deeply meaningful. They reflect our curiosity, our need for meaning, and our desire to locate ourselves in the grand story of existence. So the next time you wonder, where did the time go? Pause. Feel the now, the breath, the moment. This is time, or at least the only version of it you'll ever directly touch. In our next episode, we'll explore a different frontier, how time is represented in art, music, literature, and storytelling. From Beethoven's symphonies to Nolan's Tenet, from ancient myths to futuristic narratives, how do we express time? Until then, take your time. Welcome back to Infinity Beyond. We've explored the science, psychology, and philosophy of time. But now let's turn to something even more human. How we express time through art, music, literature, and storytelling. While science seeks to explain time, art seeks to feel it, to capture its fleeting beauty, to slow it down, to stretch it out, or even to loop it endlessly. Let's begin with music, the most temporal of the arts. Music exists in time. It needs time. A melody is not a single note, but a sequence. Harmony, rhythm, tempo, all are about time. Music teaches us how to feel time, how to dance with it, how to savor each beat. Think of Beethoven's symphonies. They rise and fall like waves of emotion. Each movement builds expectation, tension, release. Time in music isn't just measured, it's sculpted. A slow adagio can make time feel suspended. A fast allegro makes it race. Modern composers like Philip Glass or John Cage experimented with looping time, silence, repetition. Ambient music can make time disappear. Others, like Hans Zimmer, use swelling motifs to create emotional time warps, as in Interstellar, where the score literally mirrors the effects of gravity on time. In a way, music is time travel for the soul. It brings the past into the present. A single song can transport you to childhood, to a heartbreak, to a joyful memory. Time, in music, becomes emotional and elastic. Now let's turn to literature. Writers have always grappled with time, not just what it is, but how it's experienced. In traditional stories, time flows linearly, beginning, middle, end. But modern literature plays with this. James Joyce's Ulysses takes place in a single day, yet spirals through layers of memory. Marcel Proust's In Search of Lost Time begins with the taste of a madeleine, unlocking volumes of memory. In these works, memory becomes time, and language becomes the vessel to hold it. Writers like Virginia Woolf, Jorge Luis Borges, and Italo Calvino bend time, like physicists bend space, telling stories that move backward, sideways, or in circles. Even ancient myths explored time. The Greek myth of Chronos, time, and Kairos, the opportune moment, recognized that time is not just duration, but significance. Not all moments are equal. Some moments open portals. Others pass unnoticed. In cinema, time becomes visual. Directors like Christopher Nolan use time as a character. In Inception, dreams stretch time across layers of consciousness. In Tenet, time literally runs backward for some characters. In Dunkirk, he tells 3 stories over different timelines that converge into one emotional climax. And think of Groundhog Day, where time loops teach the protagonist empathy and growth. Or Arrival, where an alien language reshapes human perception of time. These stories aren't just clever, they're meditations on what time means to be human. Even in animation, time is fluid. Hayao Miyazaki's films often slow down to let us breathe, to feel wind, silence, pauses. These moments invite us to live inside time, not rush past it. In painting and photography, time is often frozen. A single frame captures a moment, a laugh, a tear, a shadow. Artists like Salvador Dali visualized melting clocks to show the surrealism of time. Others, like Monet, painted the same scene across hours or seasons, showing how light and time transforms perception. Digital art now plays with time-based media, generative visuals, looping animations, interactive timelines. Art is no longer just a static object. It can flow, adapt, evolve, just like time. And then there's memory, the internal art form. Memory is how we narrate our past, revising, reshaping, sometimes rewriting. Our autobiographical memories are stories. They're not perfectly accurate. They're emotionally true. The act of remembering is like editing a film. We cut scenes, change the lighting, add music. And each time we recall a memory, we may alter it. In this way, memory is not just stored time, it's living time. Art reflects that. Every painting, book, or film is a form of memory, an attempt to preserve time, make sense of it, or challenge it. And let's not forget storytelling, the most ancient art of time. Whether around a fire or in a digital stream, we tell stories to impose order on chaos. Stories begin and end. They have arcs. They remind us that time is not just random noise, it can have meaning, structure, and resolution. Every story is a little time machine. It transports us to other eras, into other lives, across imagined futures. And through them, we understand our own timeline a little better. So, what is time in art? It's not seconds ticking. It's not equations or calendars. It's emotion, structure, resonance. It's how we hold on to moments and let them go. It's how we remember, how we heal, how we dream. In our next and final segment, we'll reflect on all we've learned and ask one last question. What would a world without time look like? Could such a thing even exist? But for now, let a song guide you back to a memory. Let a film remind you what matters. Let a story stretch your heart across time. This is the human gift, to turn time into meaning. Welcome to the final chapter of our journey on Infinity Beyond. A journey that has taken us through physics, biology, memory, art, and philosophy. We've asked what time is, how it feels, how it bends, how it flows, and whether we can escape it. But now we confront a final, radical question. What would a world without time look like? It's difficult to imagine. Time is so deeply embedded in our lives, our bodies, our language, our relationships, that removing it feels like trying to imagine color without light or sound, without air. Let's try anyway. In a world without time, there would be no change. No before or after. No movement, no decay, no birth or death. Everything would be static, frozen in place. Without time, motion cannot occur because motion is defined by change across time. A timeless world would not just be silent, it would be still. It wouldn't even be black or white or empty, because even emptiness unfolds in time. Without time, nothing can happen. And yet, in some models of physics, especially at the quantum level, time does not appear explicitly in the fundamental equations. The Wheeler-DeWitt equation, a foundational piece of quantum gravity theory, doesn't include time at all. Some physicists suggest that time may not be fundamental, but an emergent property, like temperature, which arises from the collective motion of particles. If that's true, then perhaps deep down, the universe is timeless, and time emerges only when matter arranges itself in complex ways, like in stars, brains, and civilizations. What if time is not a backdrop, but a result? Not the stage, but the story. Let's shift the lens. Spiritually, many traditions speak of a timeless realm, a state beyond change. In meditation, people describe moments that feel like they last forever, or vanish entirely. In deep flow states, we lose the sense of time. In grief, time seems meaningless. In love, it stretches and bends. These are hints that time may be psychological, constructed moment by moment. A world without time may not be external, but internal. A world where we let go of clocks, schedules, and expectations, and return to pure presence. Perhaps the question isn't, what is a world without time? But rather, who are we without time? Are we still ourselves if we don't remember the past or anticipate the future? If we live only in the now, are we free or lost? Let's bring it home. Throughout this series, we've explored how time emerged with the Big Bang bends. With gravity and motion, shapes our bodies and minds. Influences how we feel, love, and remember is represented in art, music, language, and myth. May be rewound, or may be an illusion. We've seen that time is everywhere, and nowhere. It is real, but also flexible. Fixed, but also relative. Lived, but also questioned. And maybe that's the point. Time is not a puzzle to be solved, but a mystery to be honored. It's the dimension in which we exist, the flow we cannot escape, and yet, somehow, the very thing we try to hold on to, shape, and understand. You watching this now are part of that mystery. You are a being of time, made of stardust, shaped by moments, dreaming of futures, and haunted by memories. But in this moment, right now, stop, feel it, the breath, the stillness, the strange, fleeting miracle of being alive. This is time. This is timelessness. This is you. Thank you for walking this journey with us on Infinity Beyond. Whether you found wonder in wormholes, comfort in philosophy, or awe in quantum paradoxes, we hope you see time a little differently now. Maybe even treasure it a little more. And while we may never escape time, we can certainly make the most of it. Until next time, if there is a next time, stay curious and take your time.